In the beginning of October 2025, while the interstellar visitor 32 Atlas glided by Mars, a pair of European probes, the ExoMars Trace Gas Orbiter and Mars Express, ended up only 30 million kilometers away from it, offering the nearest glimpse any ESA mission had achieved. These spacecraft weren't built to observe such objects, yet they suddenly had to photograph something dim, remote, and in motion. The task seemed daunting. However, once the Color and Stereo Surface Imaging System, or CASIS, on the ExoMars Trace Gas Orbiter started snapping pictures, an astonishing sight emerged. Right in the middle of the shot, a subtle pale blur shifting gently downward. That blur turned out to be 32 Atlas. What's visible here isn't the comet's solid core, but rather its coma, the misty shroud of gas and dust enveloping the nucleus as it heats up approaching the sun. The actual nucleus, likely spanning only a handful of kilometers, remains too tiny to make out. Even so, the coma, which extends across thousands of kilometers, shows up distinctly. It shines faintly against the void of space, evidence that solar warmth is rousing the comet from its extended journey through the stars. As icy vapors turn to gas, they pull along plumes of dust, creating that radiant shell. Still, determining the coma's complete dimensions isn't possible yet. Its intensity diminishes rapidly away from the center, blending into the photo's background clutter. Moreover, although many comets grow extended tails reaching millions of kilometers, none appears in these views so far. At minimum, not at this point. Data from CASIS indicates that 32 Atlas's tail remains too dim, likely only starting to develop as the comet speeds toward perihelion late in the month. Nick Thomas, lead scientist for the CASIS instrument, noted that the comet is 10,000 to 100,000 times dimmer than the typical Martian features CASIS usually captures. Aboard Mars Express, things unfolded a bit differently. The probe's cameras used brief exposures, just half a second apiece versus the 5-second maximum on the ExoMars orbiter. Thus far, 32 Atlas hasn't shown up in those shots. That said, researchers haven't given up. They intend to merge various images to enhance the signal, anticipating that the subtle glow from the interstellar wanderer will emerge when the frames are combined. The two spacecraft also tried a bolder effort, capturing the comet's light spectrum. It's uncertain, though, if the visitor was luminous enough for those tools to gather useful readings. Analysis persists regardless. In the weeks ahead, experts will continue refining and layering the images, hunting for insights into 32 Atlas's composition and reactions to solar heating. On October 4, 2025, meanwhile, a navigation camera on Perseverance silently recorded an incredible event, a slender, luminous line slicing across the black Martian night. NASA's NavCam isn't intended for stargazing. It's a reliable tool for guiding the rover's movements and mapping paths. But that evening, while surveying the sky over Jezero Crater, it detected the clear signature of the interstellar comet 32 Atlas zipping by at a vast, yet relatively close cosmic range from Mars. This capture now serves as NASA's image of the week on their site. The streak appears elongated and balanced, almost artificially precise. But is that accurate? The rover's lens excels at spotting fine details up close. When aimed at distant targets like 32 Atlas, about 38 million kilometers from Mars at closest approach, each pixel spans a massive area, roughly 12,000 kilometers wide. In the picture, the vivid band stretches roughly 4 times its width. Crunching the numbers suggests it's around 50,000 kilometers in length, far larger than the comet could actually be. And this is where the issue arises. Prior observations from the Sphere X mission set the object's maximum size at 46 kilometers, assuming it reflects roughly 4% of incoming sunlight. The NavCam's band, then, is about 1,000 times longer than the true body might measure. If 32 Atlas were genuinely a 50,000-kilometer cylinder, it would have loomed huge in Hubble Space Telescope photos from July 2025, measuring nearly 23 arcseconds wide. In truth, Hubble detected merely a minuscule, indistinct speck. Therefore, the streak can't represent a real feature. It must be an imaging glitch. The most likely cause, motion blur. To image such a faint interstellar body from Mars's surface, the Perseverance team stacked hundreds of quick shots over minutes. In that interval, 3-2 Atlas shifted detectably relative to the stars. Although such images have sparked online excitement, the finest processed view of 3-2 Atlas from the Perseverance Navcam comes from this Twitter account. Check the description for the link. At the same time, multiple Mars-orbiting probes, including the Mars Reconnaissance Orbiter, were directed that evening. Multiple telescopes turned their gaze to the identical section of the cosmos. In a fleeting moment, 3I/Atlas emerged as one of the most scrutinized interstellar travelers in history, observed at the same time from both space and the surface of a distant world. However, the photo poised to resolve the ongoing dispute over its dimensions didn't originate with Perseverance. It will arrive from the elevated camera on the Mars Reconnaissance Orbiter, which captured details at roughly 30 kilometers per pixel in its October 3rd scan. This represents over 400 times the sharpness of Navcam. Curiously, though, numerous NASA sites and streams have fallen quiet, impacted by a federal government closure right when live reports are crucial. Halting vital public information amid an interstellar pass-by strikes many as suspiciously timely, particularly as scientists globally vie to track what could be the strangest entity encountered in our solar system. Buzz is already rampant. Certain experts float the idea of an unusually vigorous comet unlike any before. Others venture bolder notions, like an extraterrestrial scout, advanced machinery, or even an otherworldly vessel. Regardless of their credibility, the coincidence of this information blackout sparks suspicion. On a positive note, there's a potential breakthrough. On October 2nd, the Perseverance rover recorded a line cutting through a series of multi-minute exposures. This line deviates from the typical movement of Mars's celestial backdrop. Rather than running straight up or parallel to the star paths from planetary spin, its angle tilts and holds steady over the shots. It's genuine. It's no artifact. It's traveling swiftly. It's reasonable to suspect we captured 3I/Atlas in action. Recognition for spotting this line belongs to Drew, whose Twitter update prompted deeper examination. At present, the entity scale is still unclear, though minimum estimates hover near 5 kilometers across, and it might extend larger. It forgoes the enormous traditional dust tail of typical comets. Rather, it appears shrouded in an expansive, hazy envelope of charged particles and debris. Its velocity is remarkable, around 60 kilometers per second, building to nearly 68 kilometers per second as it approaches perihelion late in October. On or about September 25th, a solar coronal mass ejection impacted 3I/Atlas, potentially charging or agitating its vicinity. Subsequent photos from September 27th and October 2nd reveal no dramatic upheaval, no abrupt tail detachment or breakup, just subtle signs of slow swelling in its sheath. That's precisely why NASA's reporting carried such weight for observers. The forthcoming JUICE mission stands to encounter the body en route to perihelion. That said, sooner communications will hold back significant portions of that information flow. Combined, these tools might assemble a clearer image of 3I/Atlas. Meanwhile, the enigma surrounding that streak bears no ties to extraterrestrial tech, and it's far smaller than some hype suggests. But what truly defines 3I/Atlas's girth? Determining a comet's true size poses real hurdles. The trick is separating the solid core from the fuzzy aura encircling it. As a comet nears the sun, its icy components sublimate straight to vapor, hauling along dust particles into the void to create that signature plume or halo. This effect can inflate the comet's apparent size and glow well beyond its rocky heart. Recently, a Harvard group under Richard Kluta, Avi Loeb, and Peter Ves reviewed data on 3I/Atlas gathered from May 15th to September 23rd across 227 observatories globally, sourced through the Minor Planet Center. They contrasted the real path against the orbit predicted by gravitational forces alone. Their discovery, a small yet detectable nudge, under 15 m per day squared. Typically, outgassing comets experience a modest thrust from venting gas plumes. For 3I/Atlas, though, the detected non-gravitational pull is oddly subdued compared to the evident activity. This implies a dense core sturdy enough to shrug off much influence from those outflows. Based on this, The analysts project the comet's nucleus mass is more than 33 billion tons and spans about 5 kilometers, excluding the encircling haze, rendering it 3 to 5 orders of magnitude heftier than prior interstellar wanderers. Lowe contends that, considering projections for interstellar debris density and metal content in the void, we ought to have encountered plenty of smaller interstellar bodies long before this behemoth. But we haven't. This positions 3I/Atlas as a striking anomaly. Lowe goes further, pondering a provocative theory of artificial makeup, pointing to the surprising bulk, the precise orbital setup, and alleged nickel traces absent iron as intriguing clues. NASA experts, by contrast, advise restraint. The consensus holds that it's probably just a cosmic rock. From the visuals, we can tell this thing is dynamic, indicating a coma of sorts enveloping the nucleus, which is this discovery points to the object truly being a comet. At the same time, certain researchers aren't pondering the identity of Oumuamua, but rather its potential role. Astrophysicist Suzanne Fner's concept is straightforward yet compelling. Oumuamua could act as a seed for planet formation, but how might a rogue rock from a distant star system trigger the creation of a whole world? Let's explore the process. We arrive in a nascent solar system, with a fresh star at the heart of a vast, dusty disk. In this environment, minuscule rock particles drift like mist, merging into small stones. Over time, these build up into larger rocks and eventually planetesimals, the basic building blocks of planets. Eventually, they expand to draw in additional matter. The process appears simple, yet as we'll discover, a major challenge arises. Protoplanetary disks endure only a handful of million years before the gas dissipates. This brief period raises questions about how enormous worlds like Jupiter and Saturn manage to develop. Consider an alternative possibility. An interstellar visitor plunges into the disk, a chunk substantial enough to function as an instant nucleus. Rather than beginning with fine dust, the disk gains a sturdy foundation that swiftly attracts nearby gas and debris. Through this mechanism, such an extraterrestrial intruder might accelerate the emergence of a planet. Falsner's computer models back this hypothesis. Her results indicate that larger stars excel at snaring interstellar bodies compared to their smaller counterparts. Not surprisingly, gas giants tend to orbit more massive stars. The alignment of prediction and evidence is remarkable. Should this hold, wanderers like Oumuamua, Borisov, and Atlas represent more than mere passers-by. They could serve as the catalysts that launch planetary architectures. Certain ones may have nucleated gas giants in remote systems. A few might have contributed to the formative stages of our own solar system. The notion is daring and remains unverified, much like Loeb's theories. Probing interstellar objects poses huge hurdles. They emerge abruptly, zip through space, and fade into obscurity. Yet on this occasion, we've spotted it early, giving us a head start. Advanced tools might at last reveal its authentic character, instead of relying on post-facto speculation once it's departed. Music.